Hi, everyone. Thank you all for joining our session today. My name is Caroline Guo, and I'll be helping facilitate today's webinar. Our webinar today is Controlling Cloud Costs with Terraform. In our session, we'll be walking through a demo and an overview of how Terraform's features provide cloud infrastructure automation workflows and can help manage spend. During this webinar, please feel free to type your questions in the Q&A box. Please make sure that you are typing them into Q&A instead of chat. We will be sure to answer the questions in Q&A. This webinar is going to be recorded, and the recording will be made available typically within 2 to 3 business days post-processing. And with that, our speakers today are Megan Leese, Product Marketing Manager for Terraform, and Kyle Ruddy, Technical Product Marketing Manager for Terraform. And with that, I'd like to pass it over to Megan to kick us off.
All right. Thank you, Caroline. Like Caroline said, my name is Megan Leese, and I work on the Terraform team here at HashiCorp and have been here for about 4 years. And Kyle Ruddy is also here working on the Terraform team, and he's going to take over about halfway through and show us a bunch of the stuff we're going to be talking about in the demo to help manage cloud spend at scale as you're moving to kind of this multi-cloud model. So with that, we'll get started. Before we jump into the tech and examples, it's really good to set some context about what is driving a lot of these transitions in operating models for cloud. And the first part is really around the prevalence of multi-cloud. On average, it's reported that organizations use several clouds, and in some of the latest reports, it's up to 5, with about 2 or 3 of those being in production and 2 or 3 being in development or test organizations. But the reality is that there is this cloud operating model that is changing the way that we're going to build infrastructure, manage it, and then ultimately what that impact will be to the business operating model, which is spend. And that leads us into the second point over here, which is, hey, what organizations are really realizing when they look at the amount of money that they spend on cloud is some of it is excellent. It's necessary spend to help drive their businesses and their digital transformations that are happening. Application developers can build the infrastructure they need to deploy their applications. They can do it a lot faster. They can scale out. It meets all the agility needs, and all of that is wonderful. But as you look back on it, there's also some unnecessary spend, and it really goes down into 3 buckets of infrastructure. There's idle infrastructure, meaning we're spinning up resources that we're not using. Then there's orphaned infrastructure, which means that we have a project that kicks off, it maybe runs for some period of time, the project wraps up, but the infrastructure never gets deprovisioned, but it's also not tracked, so we don't know that it's there. That's what we call orphaned infrastructure. And the third bucket is around oversizing the resources. And this typically comes up when you have developers who can now self-service their infrastructure with cloud because it's on demand, and they decide, you know, it's like the analogy, I'm going to use a Ferrari for something that like maybe a Honda Accord is well equipped for. So it's oversizing it, it's picking the most exciting or biggest resources available, but also the most costly for something that doesn't require it. So it's those three buckets of reasons that organizations are realizing, hey, we're kind of unnecessarily spending on cloud 30 to 40% more than we really need to be. So the question then comes, how can I, as an operator or the manager of my infrastructure, help influence our spend, but from a programmatic way from the infrastructure up? So to look more at this, let's think about the operator's role. So we have an IT operator, and their job traditionally has always been to provision the infrastructure, and they're usually the gatekeeper to that infrastructure. So a developer needs that infrastructure, they ask operations, builds it, provisions it, configures it, and hands it back to the developers, and they have it back. However, that traditional model kind of goes by the wayside as you think about cloud now, because now we don't have just like a set of infrastructure that's provisioned for a period of time and kind of onto a target environment. We now have an infinite volume of infrastructure that's deployed frequently. So sometimes daily, sometimes multiple times a day, multiple times a week. But regardless, it's a lot more frequent than every few months. And then it's also deployed onto multiple target environments. So multiple public clouds, multiple third-party resources, like it could be monitoring like Datadog or New Relic. But these are all infrastructure types that now become part of our distributed multi-cloud environment. So those 3 core tenets along with the ability for anyone to ultimately provision the infrastructure they need, means that the cloud model has changed. And now operations is no longer the gatekeeper to infrastructure. However, they are chartered with maintaining operational consistency, or an approach to operational consistency that allows us to say, hey, what is the necessary spend we need to support our application delivery versus what is the unnecessary spend? How can we clean up some of those things that aren't really working? And our view, the three areas that have really helped organizations take a consistent approach to how they do this from start to finish. So in their first phase of cloud adoption to their scale out phase, where they're now innovating and onboarding new use cases in multiple clouds, what is that consistent approach they can take? And there's really three pillars to that. First, embed best practices into your workflow. The second one is to enforce those best practices through the use of policy. And then the final one is have a unified view of the infrastructure and the cost of that infrastructure across any of your providers. So we're going to now kind of jump into what does it mean for each of those three things. So as we talk about embedding best practices, what are the types of best practices that we care about embedding into our provisioning workflow or infrastructure workflow? The first one is, hey, if you want to have a view of the infrastructure you're using, let's make sure the infrastructure is tagged. And that's a super easy best practice. But if you think about how organizations are doing cloud, it's like, if you're going to provision anything in cloud, make sure it's tagged so we can see what that overall overarching view of infrastructure is across the different environments. The second one is, how can I restrict the types of infrastructure that my development teams can provision during different phases of application delivery? And this must best be defined by, hey, my developer is starting the development phase of the application and they want to do functional testing. They don't really need to use high scale instances. How can we say that they use maybe one of the smaller instance types for those phases of application delivery? And then that final part is like, how can I put lifetimes on the infrastructure that's being provisioned? And one such scenario is enforcing the use of a time to live variable within those blueprints for infrastructure. So these are examples of best practices that can be embedded into the actual provisioning workflow so that every time that infrastructure goes out or that blueprint is provisioned, these things happen. But that is only part of it. The second part is really, how do you enforce to make sure that people are abiding by these best practices you built into that workflow? So the first one is create a policy that ensures infrastructure does have tags. Another one would be create policies that says development or staging phases, development test or staging phases, use certain types of instances. Maybe the next one is, hey, developers can only provision infrastructure within certain hours of the day. There was a number of studies that have been read out there that says development and test and all of that generally happens within business hours. And so let's say, hey, you are provisioning infrastructure during business hours. If you need exceptions, that's fine. We can make that flexible, but let's set the guidelines that it happens when we know you're going to be using it. And then the final part is around infrastructure does not maybe exceed certain cost thresholds. So each application team might have budgets for the application development and the infrastructure required to build those applications. Let's make sure when they're provisioning the infrastructure, it falls within those guidelines. If it falls outside of those guidelines, let's have a workflow where that gets approved as an exception rather than a rule. So those are the types of policies. And then the final part is around, hey, let's view infrastructure. Some of the questions that will come up over time is, what are the number of EC2 instances I have out there? What are the costs of these instances? Or possibly, what is the cost associated with the infrastructure to run application X or application Y? And then the final part is maybe you want to see how much is the infrastructure I'm running for the development phase of my application compared to the infrastructure I'm running for the production phase. So these are all things that having visibility into both your infrastructure state and the costs associated with them will help you to understand the big picture and how it's impacting spend over time. So now I want to jump in. Those are talking about the problems. How does Terraform address this? And Terraform was built as an automation tool to say, hey, I can get up and provision my infrastructure quickly because I can provide that automation based on infrastructure as code, and it works with over, n number of providers, all the different cloud providers. So I can do that, use the same workflow for anything. However, what has become abundantly clear is because of the infrastructure as code approach, it also enables all of these other things to embed best practices within the infrastructure as code. So they're codified, they don't change, and then those get published by the IT ops team. So that's that code piece over here. All infrastructure is as code. Also, all policies become code and those things get published. The second part is this automation engine that works, and that automation engine then prints out records of the infrastructure state, as well as audit logs of everything that's happened across any of the providers. And these providers down here work with public cloud, private data center infrastructure, and third-party services like Datadog or New Relic. And this is the overarching way that Terraform works. So let's see more specifically how it addresses the three core components that we've talked about. So the first is embed infrastructure with best practices. Terraform uses this as infrastructure as code approach. So codify the infrastructure and then put it into this construct called a module. And that builds that infrastructure as code as a reusable component. That reusable component can be tested and validated by the IT ops team. And then it can be published to a module library that is accessible to then all of the development teams within the organization. So instead of them building their own infrastructure as code for the resources available, they are using ones that are already pre-created by the IT ops team, and then they're able to grab those and then initiate their own runs. The second part of that is the enforce part. Enforce best practices with policy. So Terraform uses Sentinel policy as code management to allow the IT ops team or any other team that's chartered with building policies to define the provisioning time policy. And this could be related to security, compliance, and operational best practices, all of which influence cost. Validate and approve those policies and then publish those into the Terraform workflow. At that point, then the policies are always checked at the time of provisioning so that when application developers provision their infrastructure, those policies are automatically checked to make sure that, hey, they're not doing it outside of the business hours, or they are using it within the right constructs for instance types. And then the final part is view the infrastructure state and the cost estimates. So Terraform provides two things. The first one is infrastructure state. So as we showed, there's infrastructure as code. That's in a template that gets sent to the Terraform automation engine, and it comes out with the state of the resources that were provisioned. So at any time you can audit that infrastructure state or the logs to see what infrastructure is available or provisioned at any time, but also how that infrastructure came to be. The other part is as part of this automation plan that happens, the infrastructure plan happens, and as part of that, it also gives you what is the estimated cost associated with the infrastructure that's going to be provisioned. So if you have a developer and it goes and selects, a number of modules, builds a workspace, and goes out and provisions that infrastructure, they're going to get a plan back that says this infrastructure is going to cost $4,000 over a term of a lifespan. So that's how you can start to get visibility into the costs associated with application development or the various phases. So the reason this also becomes so compelling is because Terraform works as a platform that engages both workflow partners across VCS providers, CI/CD pipelines, service ITSM like ServiceNow. So as you have development teams that are working in any one of these work streams, they can leverage Terraform as the platform to do their provisioning. And then that platform goes out and works with a variety of providers across the ecosystem. And I think there's over 200 plus different infrastructure types that have Terraform providers for them. And all of these infrastructure or workflow partners here at the top are ways that you can enable application developers to take advantage of Terraform as that single source of provisioning with the library of modules, the Sentinel policies enforced, and then the ability to see everything provisioned off across all of your workflows through that one central source. So before we jump into the demo, we're just going to recap. So Terraform provides a systematic approach to do operational consistency to control cloud spend with Terraform. And the three components are of that: embed best practices with Terraform modules using infrastructure as code, enforce those policies with Terraform Sentinel policy as code, and then provide a singular view of infrastructure with the Terraform state and cost estimation capabilities. All right, so with that, we're going to jump into Kyle's demo, and he's going to walk us through and show us how all of these components work together to deliver on that.
Sweet. Thank you very much. There we go. All right, so we're going to talk about a couple of use cases that keep coming up in some of the discussions that I've been having. And really it comes down to, trying to, when you're trying to understand some of these costs and trying to control them, how do you visualize what these costs actually are? And especially how do you do that when as part of your Terraform, plan and apply? Then how do we, take some of these policies that we have as an organization and now apply those to our infrastructure in the way that it's being deployed? So we're going to check out some policy as code usage as well. So let's jump over to Terraform Cloud here. So I've got a couple different workspaces set up. You can ignore the bottom part there. We'll start with this basic site demo. So this is linking back to a fairly simplistic Terraform configuration file to deploy out a website, as well as taking advantage of some other things that AWS has to offer. So I'm going to set up the queue to see how that goes. Because in normal operations, like the first time that you run this, you're just going to get your plan and then you can hit the confirm button. However, we're being a little more conservative about our costs here. So we want to know exactly what's going to happen as this runs and as this turns into actual provisioned infrastructure. So we've enabled cost estimation for our entire organization here in Terraform Cloud. It's just a very simple checkbox that goes out and applies to the entire org. Then, as part of your runs here, you're going to see this cost estimation queued that lines up. So as part of this plan that I've created here, we have two different resources that have costs associated with it. One is the load balancer. We can see that this is going to be about 2.5 cents per hour, as well as a compute instance. It's going to be a little over 1 cent per hour. We can see some other information like how much it's going to cost monthly, and so that we have a really good idea of what this particular instance is going to cost. Now we can also build on top of this, so just identifying the cost is really the first step. So we're going to go ahead and cancel this run. And we're going to integrate in some policies, some policy as code using Sentinel. So for that, we can head over to settings, jump into policy sets, and I've already created one that's called cost estimation policies. So in there, I've already applied it to the two other workspaces that I'll show here in a second. There we go. Add in our workspace there. So we can see that it's been successfully added. We'll go back and set up our queue again here. So again, it's going to go out, check out our configuration that's out living in GitHub. It's going to verify and say, hey, those 9 resources that you just planned, we're still going to want to deploy those. It's going to give us the cost, and then it's going to add some intelligence around policy as code with some of these Sentinel rules, and I'll show those here in a second as soon as this finishes up. Yeah, so again, we're adding 9 new resources. Then cost estimation is going to come up. You're going to see the exact same figure, about $26.35. And then our policies have ran. Now for this particular demo, I focused on 2 main Sentinel rules. The first one is around cost. In this particular situation, we're looking to make sure that the proposed monthly cost is less than $10. Now, of course, we can look up above and see that the load balancer that we're using alone is going to be above what our cost threshold is. Now, a nice part about Sentinel is that we can say, this is just an advisory level thing. If you're really certain that you want to deploy it, go ahead. Then our second policy that's down here is checking on time. So, I'm a big advocate for read-only Friday. Don't want to deploy anything new, either mess up an environment or, run it over the weekend. Because what happens if you run this over the weekend? At roughly 3 cents almost 4 cents an hour. That works out to about $2, running that over the weekend. Now that doesn't sound like a lot, but when you have, 10 developers, 100 developers, and even more, those costs really start to add up. So you want to, kind of control those. So here we're again gonna cancel this run, and we're gonna go into it and build it out just a little bit more here. So we're gonna use the same configuration, but a little bit different branch. So now we're turning it into, trying to make sure that we're verifying that the infrastructure that we're deploying is going to be consistent. We're looking for that uniform application that every single thing is deployed in a consistent manner. So here I'll set up our queue plan here. It's going to look very similar to the last one. Our cost estimation is going to look the same. And actually here, while that's running for the first time, I'll show you the cost estimation policies that I created. So the first big one is just looking at the AWS time. We're importing our time package, pulling out the weekday. That weekday is a number. And then we're just checking to make sure, does that weekday value equal 5? If it does, fail it. If it doesn't, it's true, it passes. Let's see where our run's at here. So again, same deal. It's still going to be above, the $10 per month, but it's still not Friday, so we're all good there. Now let's go back to our Sentinel HCL here. Do not judge me for modifying this directly in GitHub. That is just for simplicity's sake. So what we're going to do is add this new rule on top of that for the AWS instance type. So we want to make sure that whatever instance is being ran, it falls in line with our organization's policies. So we're going to queue that up again, and I'll show you the policy that I created for that. Looking at our instance type, we're doing this, setting it down by, or configuring it by workspace name. So if it's a prod environment, production environment, we're going to use a t2.large. If it's a development environment, we're going to use t2.micro. Let's head back over to here. Plan is still running. Here we go. And this time, as soon as our policy check queues up, we now see that we have 2 passes and 1 failed. Let's see, go down to, so here's our logging output right here, just saying that we're checking to make sure that this particular workspace is using a T2 micro instance. So we'll go ahead and cancel this run and take a look at our prod. Because the other important thing when you're working with policy as code is, knowing the difference between, when you want to outright fail something and when when it's just acceptable to allow folks to keep running. So for that, the enforcement level is what Sentinel calls that. So what we have is advisory, which is what we saw with the costing. Then we have a soft mandatory and a hard mandatory. And if we go back to our production side over here, again, we're adding the 9 different resources. And then now our cost estimation is going to kick in, and we're going to see a little bit of a difference here. So in this case, our compute instance, it's a little more expensive. We've gone from, $26, $27 up to almost $300. So running a production instance, you have to be that much more careful about what's happening there. Then if we look at our policies in particular here, we can see that we have our, AWS costing, this is absolutely going to be above and beyond the $10 spend. But we're going back to that instance type again, and we're looking to see, is this running a t2.large? And I could include it in the debug log, but I figured this is a good chance to actually go through and check out our configuration here. So in this case, this configuration is trying to use a T2 2 extra large. So a little bit of a difference, and it kicks our plan completely out. One other thing that I want to call out while we're in here, While we're talking about Sentinel policies, are these foundational policies that we've created. It's a repo that's out there. It's on GitHub, just like all the other resources that are coming from HashiCorp. And it's really just a nice set of pre-written Sentinel policies you can make use of. Instead of having to go through and write your own or Google up your favorite policy, that's a really good resource. And I'll share a link to that here shortly. So with that demo, that was just a really simple way to go through and see how we can start using cost estimation with your Terraform configurations. Just a simple checkbox applies that to your entire org. So you can start doing that for every single run that you do. Then we started to apply some policy as code to those configuration runs so that we can plan for things such as, modifying cost limitations, making sure that people don't spend too much, making sure that we're, applying to corporation guidelines, making sure that nobody's trying to apply things on a Friday or during the weekend. And then lastly, making sure that everything, our development environments are all the same, making sure that our production environments are really all the same. So with that, there's a couple resources that you're going to want to check out on top of this. That entire demo was done using Terraform Cloud. It's free to sign up. It's just app.terraform.io/signup. You can get started immediately. And really that's one of the big things that's really nice, especially when you start to work on remote states, which really, hopefully everyone here is doing. Because it's really hard to collaborate with other folks on your teams, and especially now in this remote world that we live in, when you're working with a local state. I was recently discussing it with some community members, and one of them happened to bring up that they thought that Terraform Cloud was by far the easiest way to manage remote states available. So really cool shout out from that particular member of the community. We also have the Terraform registry. It is amazing how much this thing has evolved over just the past couple months. It used to just be the HashiCorp created and supported modules and providers that were out there. However, earlier this year, it really changed. So now there's not only the HashiCorp provided ones, but there are also ones from our partners as well as the community too. And then lastly, policy as code is something that's extremely cool to start using and applying to configuration, very powerful. And so that pre-configured set of policies that we've created and released that are out there, it's called the Foundational Policies Library. And right off the bat, we've released a set of policies that apply to CIS, or the Center for Internet Security, benchmarks that apply to the public cloud resources. And it's really simple to do it. You just use a source parameter, toss that in your Sentinel file, and you're good to go. So really nice from that aspect. So with that, I'm going to hand it back over to Carolyn for some Q&A.
Awesome. Thank you, Kyle, and thank you, Megan. Before we hop into Q&A, I did want to start a quick poll to see if any of the folks who've joined us today would like a follow-up from our enterprise sales team. And while I launch that, we can pop over into Q&A. So if there are any questions at this time, please type them into our Q&A box and we'll go through those. So currently we have one question about cost optimization as being a part of the Terraform certification. So I will preemptively say that this team here doesn't manage the certification process, so we can take a look and get back to you. Megan or Kyle, do you all know if cost estimation's on certifications?
Yeah, I think we'll have to follow that up at a later time. I'm not sure. I think they're just rolling out a bunch of that stuff, so it might be coming soon.
Okay, great.
I'll add a little bit of color there. There is a section, I believe, on just some high level policy as code stuff, but I don't believe there's any requirement to know any like the nitty gritty. I don't think they're going to expect anybody to write their own policies as part of the exam right now. But,
Okay.
but at least understand the concept of policy as code.
Okay, great. I sent out a link to our Learn site that goes over a high-level overview of our Terraform certification, so that should provide an overview of what's all included. All right, the next question is costs and policies, as in Sentinel, are these only available for Terraform Enterprise?
Yeah, I can take that. The cost estimation, so I'll just walk through the ability to do modules, provide policies, and use cost estimation is all available within Terraform Cloud or Terraform Enterprise. There are some of those features in Terraform that cost money, and some of the stuff would be free. So go check out the Terraform pricing page, and it has the breakdown of what's available in Terraform Cloud and Terraform Enterprise. And I think we can send that link out as well in our follow-up email.
Yes, I believe the link is hashicorp.com/products/terraform/offerings. But we will send that out in the follow-up email as well. Okay, a couple questions from Mark. For Terraform Cloud, where are the pricing tiers regarding features and functions? For example, are policies included in the free tier, etc.? So I think this does go in line with the question that was just asked. The full tiering of all the features and the functionalities within each of our team and governance tiers are listed on our pricing page, which I will pull up and I'll send them over into the chat. All right, we'll drop them into. All right, that should be the link. Okay, next question. Are there limits on the numbers of policies that can be applied? And if so, what are they?
I will defer to Kyle on that one. I don't believe so.
Yeah, there's no limitations that I know of, and as part of how many you can apply. Some of them, some of the ones that I've seen get pretty big. So there's no limitations that I know of.
Okay, great. Are the Sentinel audit logs exportable from Terraform Cloud or Terraform Enterprise?
Kyle, you want to take that?
Sure. That I don't know off the top of my head.
Okay, we can.
I believe that's a TFE thing, or a Terraform Enterprise thing right now.
Okay, so not available in Terraform Cloud, but we can confirm.
Yes. Correct.
Yeah. So yeah, just like we can take a step back. So the audit logging capability is currently only available in TFE. So the export of that would definitely be limited to TFE. I believe that there are some integrations to export those that we have customers or accounts doing. Yeah. So but we could follow up in the thing on the documentation and the details of that.
Okay, great. Next question. Are there any granular permissions in regards to who can author policies? And if so, how is that managed?
Kyle? Right now, no. So what's happening in Terraform Cloud and Terraform Enterprise is that you're using policy sets. So somebody who is an administrator for the organization configures those policy sets, which are basically pointing them to your VCS of choice, GitHub, GitLab, whoever you're using, and so that's how that link is being made. So basically, if you can make a commit to that repository where your policies are being held, then you have the ability to do that. There's nothing inside of Terraform Cloud or Terraform Enterprise that would limit that.
Okay, great. And then we just have two more questions. The next question is, what, if any, reporting features are available for policy histories? For example, if they've passed failed.
Go ahead, Kyle.
So that's, I mean, so when it comes to Terraform Cloud, you can go back through your previous runs, and you can, those are stored in history. So if I went back to my workspaces, I could, see what succeeded, what didn't, and you can have access to that. When it gets over to the Terraform Enterprise side, that's going to be more of the audit logging. That's going to be able to give you that type of information. Though, if you want to, pick and choose through certain runs, you can do that as well.
Okay, great. And then our final question from our webinar today. Someone has asked, can I set up a VPN or AWS Direct Connect using Terraform? If yes, would the cost estimation also include the estimated charges for data transfer?
Oh, no. As far as data transfer, that would not be something that shows up in cost estimation. That is something that's very environmentally dependent. On what your environment is set up.
Okay, great. Okay, we just have one more question that just popped in. Is there a way to modularize pieces of Sentinel policies? For example, if you have a function to pull out any type of resource from the plan, can that be modularized and used in multiple policies?
Yes, yeah. So one of the nice things about policy sets, which is something that's on the new side still, is that you can take those individual Sentinel rules and apply that at the higher level, so that you only have to write your rule once. It can apply to several different organizations. It can apply to several different workspaces. Just that demo alone was one, using the same exact policies to apply 2 different rules to the workspaces, one being that dev and one being the prod. So, you can take that additional steps and apply that to other environments, other organizations as well. So yeah, it's very modular.
Okay, great, thank you. There's one last question about if we'll be doing Azure events, and I can answer this. So if you're looking for any of our upcoming HashiCorp events, we do focus on different cloud providers across some of our different events. So if you take a look at hashicorp.com/events, you'll be able to see the upcoming list of all of the digital webinars, workshops, SE Hangouts that we have. Okay, great. So that covers it for all of our questions today. Thank you all for those great questions from the audience, and thanks to Kyle and Megan for helping answer those. I hope everyone enjoyed today's webinar, and you all have a better understanding of how Terraform can help your organization control cloud spend. You can get started today with Terraform Cloud by signing up for a free account at app.terraform.io. And then for any Terraform Enterprise questions, you can reach out to someone on our sales or SE team at hashicorp.com and fill out a contact sales, demo, or pricing request form. And finally, as I mentioned at the beginning of our webinar, this webinar has been recorded, and we will be making this recording available 2 to 3 business days post-processing. All the folks that have registered for the webinar will receive a recording email link. All right, thank you everyone. Have a great day.